Hello and welcome to this presentation on modern technologies and sensors. In today's world, technology is constantly evolving from smart homes to wearable devices and self-learning cars. But behind all of these innovations lies one key concept called a sensor. Sensors are key tools that help computers understand what's around them and makes them feel about it. So without sensors, even the most advanced computers in the world wouldn't be able to sense anything around them. Over the next few minutes, we'll learn how sensors work, explore two most important types of sensors, and finally bring them together in Hansonic's example project called Smart Home Alert. Let's start by answering a simple question. What are sensors? And why are they so important to us? So a sensor is a device that can detect changes in the environment and turn to signals that machines can easily understand. So, for instance, a temperature sensor might detect heat and send a voltage signal. A motion sensor might detect the distance using sound waves. The microcontroller, like Arduino, reads the signal and decides what to do next. Think of sensors as a way machines feel, see, and hear the world. In this station, we will focus on two common sensors: ultrasonic and temperature sensors, because they demonstrate both digital and analog sensing. We'll also explore how combining them can make a simple but powerful smart systems.
So what exactly happens inside a sensor? Every sensor has one main job: to measure a physical quantity such as heat, light, or distance and convert it into an electric signal. This signal can then be processed by a microcontroller, which interprets it as data. For example, a light sensor doesn't literally see light. It measures the brightness and outputs voltage that changes with the intensity. Once that signal reaches the microcontroller, it can trigger their actions, such as turning on lights, adjusting fan speed, or sending a notification to your phone. In short, sensors can act as bridges between physical world and the digital world. To make this easier to understand, let's compare sensors to human sense. A temperature sensor works like your skin. When it's hot, your skin feels warm, and when it's cold, you sense that change immediately. An ultrasonic sensor is like a bat's sense of hearing. Bats send out a high-pitched sound that bounces off nearby objects, letting them see even in total darkness. And a light sensor acts as your eyes, detecting how bright or dark it is. This analogy reminds us that sensors give machines their own kind of perception. They allow electronics devices to notice what's happening around them and to respond intelligently.
Let's dive deeper into one of the first two sensors, ultrasonic sensor. So an ultrasonic sensor measures distance using sound waves, but not the kind of sounds we hear. They use ultrasonic frequencies, which are much higher. That is why we mostly use ultrasonic sensors to detect objects without physical contact in robotics and automation. Now, let's look at another common sensor, the temperature sensor. A temperature sensor measures how hot or cold something is by detecting changes in its electrical resistance or voltage. So when the temperature rises, the resistance or voltage changes, and the microcontroller reads that variation as an analog value. So the sensor doesn't say hot or cold directly, it just outputs numbers. The microcontroller interprets those numbers and takes action, like turning on a fan when it's too warm or turning on a heater when it's too cold. That's how a temperature sensor works.
Now let's take a quick moment to recap digital and analog signals, now that we've seen both in action. A digital signal is like an LED turning on when motion is detected. It's either 1 or 0, no in between. An analog signal, on the other hand, continuously changes. For example, a temperature sensor's readings might shift gradually from 320 to 450 to 700 as the heat increases. Both types are important: digital signals for clear decisions, analog signals for measuring changes precisely. Together, they help microcontrollers respond to the world in a logical, human-like way. Now that we understand both ultrasonic and temperature sensors, let's put them together in a simple project, the Smart Door Alert. This concept project combines the two sensors with a microcontroller and a display. The idea is to make a door system that can detect visitors and also check the outside temperature. It's a fun way to see how sensors communicate and how microcontrollers process information to make smarter decisions.
Here is how the Smart Door Alert works in action. When someone approaches the door, the ultrasonic sensor detects motion and sends a signal to the microcontroller. The microcontroller responds by flashing an LED light on the other side of the door to the user, letting the user know someone is behind the door. Or at the same time, a temperature sensor measures outdoor temperature. If it's cold, the display might show a blue color. If it's hot, it might show red. You could even add a buzzer, display a message, or a Wi-Fi alert. The project demonstrates how simple components like ultrasonic sensors and temperature sensors and microcontroller can create a smart and interactive system. And that's the end of our video into the world of sensors. We have seen how sensors act as sense of machines, allowing them to detect, interpret, and respond to their surroundings. From ultrasonic devices to temperature measurement, these technologies power everything from everyday devices to advanced robotics. I hope these videos help you understand the invisible but essential role sensors play in modern technology. Thank you so much for watching this video, and remember, every great invention comes with sensing the world a little differently.